Why does specific heat vary with temperature? Imagine heating a pot of water and noticing that it takes different amounts of heat to raise the temperature at different points. This is because specific heat, the energy needed to warm up a substance, actually changes as temperature changes. It might seem strange because we often think of it as a fixed number, but in reality, it varies. This variation happens because the way particles store and absorb heat depends on their microscopic behavior. At lower temperatures, particles mainly store energy as vibrations or simple motions. As the temperature increases, these particles gain enough energy to rotate or vibrate in more complex ways. This means more energy is needed to increase their temperature further. Think of it like a car engine. At first, it takes less effort to get it moving, but as it speeds up, more effort is needed to push it faster. When a substance approaches phase changes, like melting or boiling, its specific heat can spike. This is because energy goes into changing the structure of the material rather than just raising its temperature. Even without phase changes, the arrangement and bonding between particles can shift with temperature, affecting how much heat is needed. At very low temperatures, quantum effects come into play. These effects limit how particles can absorb energy, making the specific heat smaller. As the temperature rises, these quantum restrictions lessen, and the specific heat increases until it reaches a more stable value at higher temperatures. The difference between specific heat at constant pressure and constant volume also varies with temperature. When heating at constant pressure, the material can expand, so extra energy is needed. This difference depends on properties like how much the material expands, how compressible it is, and its density, all of which change with temperature. In real-world applications, engineers need to consider how specific heat varies with temperature. For example, water's high specific heat and its change with temperature make it perfect for temperature regulation in climate control systems or engines. Knowing this helps in designing more efficient heating and cooling systems. Understanding that specific heat is not a fixed number but depends on temperature makes thermodynamics more practical. It shows how energy transfer and material properties evolve as things heat up or cool down, giving us a clearer picture of how everything around us responds to temperature changes.